Okay, assembly of auxiliary panel. We're going to be placing these standoffs in place. These standoffs stop the connectors, the back of these connectors, touching the aluminium plate. So it's very important that they're in place. These are an upgrade to the previous insulating tape method and washers that we've used. They provide a much better solution. Okay, this is the order in which they go in. As you can see here, we have the one with no arm, with an arm missing on this side, and the two double arm versions are placed in these two locations here. Okay, putting them on is a little bit fiddly, but I'll show you how that happens. So we'll take them off. We put one on at a time. This is the one that goes on this end of the board. We take the screws, pass them through from the back of the aluminium plate, and place the little standoff in place. We pass the screw through the front, like so, and there you can see the two screws in the standoff. We take the PCB and we put it onto those two screws to start with. Alright, and the reason we can do that is because the PCB is flexible. Then we use a single clear plastic washer and a nut on the back, and we turn the nut to place it on hand tight, and same on the bottom. A single washer goes in place, followed by a M3 nut, and again place it on hand tight. Now, as I said, the PCB is reasonably flexible. What that allows us to do is to fiddle this one into place. So we need it to be this way round. It can drop into place, and we put the screw ready to thread through the hole. So as we drop it, have a little bit of fettling, as it's called. We lower it into place. Oops. Let's lower it into place there. Okay. We'll push it up. There we go. Line it up with a hole. Give it a squeeze and push the screw through. Single plastic washer in place, and then the nut goes over the top. Again, place it on hand tight. Okay, then we put the other screw in to the bottom hole. Single plastic washer, and the nut goes into place, and again just hand tight. And then we have the last one this end, which is this last standoff. Goes into place there. Again, we get it into place. A little bit of fettling to get it lined up with the hole, which is of course very fiddly. You can use the slight flex in the PCB to flex it up out of the way. Make sure the holes line up. Give it a squeeze. Place the screw through the hole. Single plastic washer in place, and then the nut placed hand tight, and the last screw goes into place, and the last washer and the last nut. Okay. Next, we can use the small crosshead screwdriver. Place your finger on the back of the nut and rotate the screw to get it just taut. We'll again be tightening it up even more later. This just takes it up that little bit further. You can see there the standoff is in place. Let me do the center one. Put your fingers on the back of the nuts, and we can do the screws up tighter. The last one, fingers on the back of the nuts, and we can do the screws up tighter, like that. Right, so we're quite happy with that. Next, we need to place the connectors from the BNC, connect them to the PCB, and you'll see that these two pins are actually bent over. This is to allow them to fit inside the housing. You have to make sure that the red wire is on this side. So looking at the back of with the PCB at the top, the red wire is always the one on the right. So we slide it on there, and you'll notice the red wire is the one on the right. Slide it on there, the red wire is the one on the right. You'll also notice that because of the way we've done the connectors, the red wire, that you don't see the little brass crimps here. And that doesn't matter, we slide that on there, red wire is the one on the right. You can always double check the red wire. Now you notice the red wire is the one that goes to the center pin of the BNC. Make sure we don't accidentally cross some of these over. Almost done. There we have all the connections in place. That is the board assembly complete with standoffs. We do need to tighten up those screws with a pair of pliers, which I will grab hold of. Okay, this is the assembly of the front panel. We have just a few minutes to go. First thing first, we connect together all of the header pins to the BNC. All the way across, ensuring the polarity is correct. Okay, right, they have to be flattened down to fit. 4 brass screws. 1, 2, 3, 4. Normally you get a fitting kit like this, everything would be inside. In this case, 4 brass screws, 30 millimeters long, and we poke them up through the front panel. And the other screws. Down again. Right, next we have these plastic frames which needed to be fitted in place. One on one side, one on the other. Remembering of course to get the screws to fit through the holes in the end of the plastic frame. Supposed to be easy. It's supposed to be easy. There you go, there's that one. And on the other side. There we go. Right, now we have to fit the rear panel on, but we have to fit the box header in. And we have to fit the box header through the plastic frame. Like so, probably have to lift up the plastic frame very slightly. Give ourselves the space to fit it in. And then it pushes in place, like so. The rear frame goes on, the rear panel goes on, the brass screws get pushed through. Like so, just as one big sandwich. Like so. Right, next we have to put a brass washer and an M3 nut. We have to start one at a time. Squeeze together, brass washer, M3 nut. Initially put them on so they are hand tight, like so. To the other end, squeeze, squeeze, brass washer, like so, M3 nut, hand tight, brass washer, like so, M3 nut, like so. In hand tight, and brass washer, just the one, right there, and an M3 nut. There you go. Next, we just use a screwdriver in the front, hold the nut at the back, and screw the screw. And to the other end. Next, we use the full-size screwdriver, hold the nut, give it a final tweak. The other end. There we go. All done. One assembled auxiliary patch panel ready for testing. Testing of auxiliary panels. First things first, inject a test signal into the BNC onto the front of the device. In this case, that's 10 volts, as you can see over there. So there's the BNC signal going in. We have this test cable. The positive voltage at in this stage is on the center pin. The negative voltage is on the outer edge of the black pin. Right, what we need to do is to measure the output voltage on the output pins. So the output pins in this case are P and N, N being positive in this case, and P the negative signal. So we place the probes in those two pins, hold it carefully, and we can see on the multimeter we currently have just over 8 volts coming out, 8.14 volts. All the switches are in the down off position. This means we should get the raw voltage coming out, but the raw voltage is 10 volts. In this case it's been clamped at 8. It's very important to see that it's clamped at 8 volts, because that means the protection diodes internally are working. Right, to test the device we have to switch the individual gain switches on one at a time. We're going to start off with switch number 4. As we lift up switch number 4, we should get 50% of the input signal. Now in this case the input signal is 10 volts. We're reading 4.97 volts coming out. That's as near as damn it 5 volts. Okay, we'll go to the next switch, put that switch back down, it'll jump back up to the clamped 8 volts. Switch 3 gets raised, and you'll see the output voltage is 3.3 volts. It's a third of the input voltage. Right. The next switch, is 2 volts. That's 20% of the input voltage. And the last one, we get 11.11% of the input voltage. So we get 1.11 volts. All right. That means that all of the resistors here are working. When we ship the device, we have switch 1 up and switch 4 up. That means we are outputting 10% of the input voltage. You'll see here the voltage is currently 1 volt with a 10 volt input signal. Okay, leave it in that position and move on to the next channel. Thank you very much.